Velan is a global manufacturer of industrial valves with over 1,800 employees and 13 manufacturing plants located in 9 countries around the world. The Velan Universal Steam Trap was introduced for the first time in Canada and the United States in January of 1950. In those days, the predominant steam trap technologies in use were cumbersome, inefficient, and required frequent maintenance. Founder and CEO Mr. A.K. Velan set out to design a steam trap that was suitable for the high pressure and high temperature operating conditions that naval vessels and thermal power plants were being designed around at the time. The operation of this new steam trap was based upon the principle of a free-floating and rotating ball valve placed on the downstream side of a stellite valve seat and being actuated by a multi-segment bimetallic element. The result is a steam trap that combines effective condensate drainage with high energy efficiency and long service life. The dominant steam trap technologies today are similar to those in use when Mr. Velan set out to change the world of steam traps in 1950. For example, the thermodynamic disc trap is the most popular design used across all industries today. First patented in 1878, the thermodynamic disc trap operates on the difference in flow velocity between a liquid and a gas. When liquid is being passed through the trap, the disc is pushed out of the way of the flow path, allowing free discharge of condensate. However, when steam or air enters the trap, the velocity of the flow increases and the disc is pulled toward the seat. When the steam which is keeping the disc closed condenses, the trap opens and the cycle repeats itself. For demonstration purposes, we have fitted a thermodynamic steam trap in our test rig to show its discharge characteristics. We have also fitted a magnetic liquid level indicator to show the level of condensate in front of the steam trap. Please note the operation when the condensate is completely purged from the line. The cycling action of the TD trap results in drainage of the condensate in the steam line. However, the violent blast discharge results in large amounts of steam being lost during each cycle, as high velocity steam flow is necessary to end the discharge cycle and close the trap. Many manufacturers of thermodynamic steam traps claim that flashing condensate is responsible for ending the discharge cycle and closing the trap. However, as this flow test on boiler blowdown demonstrates, the TD trap will not close in the presence of saturated condensate. Only steam flow through the trap will end the discharge cycle and close the trap. Laboratory testing shows not only that steam loss is necessary for the TD trap to operate, but also allows us to measure the amount of steam loss during each cycle of the trap. The average steam loss required for a thermodynamic trap to function is over 0.03 of a pound of steam per cycle. At current energy costs and a cycle rate of 6 times per minute, the amount of steam required to operate a fully functional thermodynamic steam trap is in excess of $1,000 per year. The amount of steam loss necessary to operate a population of 1,000 thermodynamic steam traps is in excess of $1 million annually. The inverted bucket steam trap is widely used across all industries today. First patented in 1911, the inverted bucket trap operates on the difference in density between steam and condensate. This trap uses a bucket, open on the bottom, to operate a lever valve and orifice located in the top of the trap. In the absence of steam, the bucket sinks to the bottom, keeping the valve in the open position and allowing for free discharge of condensate. When steam or air enters the trap, the bucket becomes buoyant and floats to the top, closing the valve. When this steam condenses, the bucket sinks to the bottom, opening the lever valve and discharging the condensate again. During normal operation, steam is continually lost through the air vent in the top of the bucket and periodically discharged through the valve as the bucket loses buoyancy. For demonstration purposes, we have fitted an inverted bucket steam trap in our test rig to show its discharge characteristics. We have also fitted a magnetic liquid level indicator to show the level of condensate in front of the steam trap. Please note the operation when the condensate is completely purged from the line. Testing shows loss through the air vent to be approximately 3 pounds of steam per hour. This steam loss occurs throughout the entire life of the trap. At current energy costs, the amount of energy lost due to the operation of the air vent is over $250 per trap annually. In a plant with a population of 1,000 inverted bucket steam traps, the amount of energy lost due to the operation of the air vent is over $250,000 annually. The most common cause of failure for an inverted bucket steam trap is loss of water prime. As this demonstration shows, if the water prime is lost from the inside of the trap body, the high velocity flow through the trap prevents it from repriming. Loss of prime can be caused by exposure to superheat, improper sizing, mechanical wear, or simply too rapid a startup. The Velan steam trap offers an efficient alternative to conventional steam trap designs. Operating on a thermostatic principle, the Velan steam trap requires no more energy to function than is present in the condensate that collects at the drain point. At ambient temperatures, the bimetal element is relaxed and the valve is open wide, allowing for rapid discharge of cold condensate and non-condensable gases at startup. As the temperature of the condensate increases, the bimetal element pulls the valve closed. In the presence of live steam, the valve remains closed tightly. When condensate in the line cools slightly, the line pressure overcomes the closing force of the bimetals, and condensate discharge resumes. In the event of a sudden drop in upstream pressure, the valve and seat arrangement acts as a check valve, preventing reverse flow in the system. For demonstration purposes, we have fitted a Velan thermostatic steam trap in our test rig to show its discharge characteristics. We have also fitted a magnetic liquid level indicator to show the level of condensate in front of the steam trap. Please note the operation when the condensate is completely purged from the line. The Velan steam trap provides rapid, efficient startup of steam drip leg and tracing systems. Due to the advanced design of the bimetallic element, the Velan steam trap maintains no more than 18 inches of condensate ahead of the trap at any time, ensuring efficient drainage and preventing the loss of live steam. Compare the discharge of the Velan steam trap with the thermodynamic disc trap below. The Velan steam trap will save over $1,000 annually over that of a thermodynamic disc trap. In a plant with a population of 1,000 steam traps, this is a savings of over $1 million annually. Compare the operation of the Velan steam trap to the inverted bucket trap below. A Velan steam trap will save over $250 annually over an inverted bucket steam trap. In a plant with a population of 1,000 inverted bucket steam traps, this is a savings of over $250,000 annually. Velan steam traps are manufactured in compliance with all major international quality standards, using the most durable materials available today. Dedication to continuous product improvement and on-time delivery make Velan a worldwide leader in the design and manufacture of steam traps. For over 60 years, Velan has been the steam trap of choice when durability, rugged construction, energy efficiency, and critical drainage requirements are needed. To start saving energy at your facility with the Velan steam trap, please contact your local representative or visit www.velansteamtraps.com.